Today in class we worked on solving systems of equations with elimination. Next we're going to work on solving systems of equations using substitution. When we solve systems of equations by substitution, this works best when one equation has already been solved for x or y. So when we substitute something, just like in basketball, when you are substituted in, you trade places with your equivalent. Or if you're in football, when you have a substitute in football or you trade in people, they go in for the person they're the same as. In our first example, we have 2x plus y equals negative 1, and then we have x equals 2y minus 13. So for this problem, we have one equation that's in standard form and one equation that has been solved for x. Now what's going to happen is we're going to take the equation that has been solved for x and we're going to use what it's equivalent to plug in for y. So our second equation's been solved for x. We're going to take this 2y minus 13 and we're going to plug it in place of x. Now, when we plug this in for x, we write our equation 2x plus y equals negative 1. Now, we're going to put in for x 2y minus 13. Everything else in the equation stays the same, but when we plug this in, we're going to plug it in parentheses. So replacing the x is the 2y minus 13. Now our equation says 2 times 2y minus 13 plus y equals negative 1. The benefit of having this equation is that there are only y values now, so we can figure out what the value for y will be in our ordered pair for our solution. We're going to distribute our 2 in front of parentheses first. So 2 times 2y is 4y. And then 2 times negative 13 is a negative 26 or minus 26. Then we have plus y equals negative 1. We're going to combine like terms. We have y. On the left, we've got 4y and plus y. So 4y plus y is 5y. Minus 26 equals negative 1. Now as we solve for y, we're going to add 26 to both sides because we need to get the y by itself. So we're going to add 26 to the left and the right. We get 5y equals 25. And when we divide by 5 on both sides, we find that y is equal to 5. So we found the y value for our ordered pair. Now we need to find the x value. We can plug in this y value into either equation. We can plug it in the first equation or the second equation. I'm going to go ahead and choose to plug it in the second equation. We have x equals 2y minus 13. When we plug in our 5 for y, we have 2 times 5 minus 13 is equal to x. 2 times 5 is 10. 10 minus 13 is negative 3. So x has to equal negative 3. Remember, the solution to an equation or a system of equations is an ordered pair. So our solution would be negative 3 for the x value and positive 5 for the y value. This is a point that would work in both equations. I can plug it into the first equation and it will work, or the second equation and it will work in that as well. We're actually going to check it now on our paper. We're going to plug in negative 3 for x and a positive 5 for y. So in our first equation, when we have 2x plus y equals negative 1, we plug in negative 3 for x. We plug in a positive 5 for y. So 2 times negative 3 is negative 6 plus 5. Negative 6 plus 5 is negative 1. So this works in the first equation. My ordered pair is a solution to that equation. Then we're going to plug it in the second equation. X equals 2y minus 13. Our x value is negative 3. Our y value is 5. So when we have 2 times 5 minus 13, 2 times 5 is 10 minus 13. Negative 3 equals negative 3, so this ordered pair works in that equation as well. In order for it to be a solution to the equation, it has to work in both equations. So for now, we have a solution, pardon me, that worked in two equations. So our solution for this is negative 3, 5. Taking a look at the second example, we have 4x minus 3y equals 15. We get that y equals 4/3 x minus 7 is our second equation. Our first equation is in standard form. Our second equation has been solved for y. So for this problem, if we know that y is the same as 4/3 x minus 7, we can take this value and put it in for y. So when we have 4x minus 3y equals 15, we're going to replace the y with 4/3 x minus 7. Everything else stays the same, but instead of y, we're putting in what it's equivalent to. If they're equal, they're the same, so this is just like replacing it with what it's the same as. 4/3 x minus 7. Alright, now our equation only has x values, so we can solve for x. We're going to distribute the negative 3 in front of parentheses. Negative 3 times 4x, or 4/3 x, is a negative 4x. If I multiply negative 3 over 1 times 4 over 3, that would cancel out my 3 on top and bottom, and I get negative 4. And then negative 3 times negative 7 is a positive 21. Everything else in the equation stays the same. I bring down my equals 15, and I bring down the 4x in the front. Now we have 4x minus 4x. I am going to combine like terms. Well, 4 minus 4 is 0, so 4x minus 4x cancels out. I would get 0x, and 0 times anything is itself. So now we have 0x plus 21 equals 15. 0 times x is 0. 0 plus 21 is 21. So now we have a statement that says 21 equals 15. Just like yesterday with elimination, if I no longer have a variable and I have a statement with two numbers, it says 21 equals 15. That's a false statement. So for this, there is no solution. There is not an ordered pair that would match with these two equations. And if I graphed these, the graph of these two equations would look like two parallel lines. So there are no solutions. There is not a point that would work for an ordered pair in both of these at the same time. Since there was no solution, we cannot check this. If we did have a solution, we would check it by plugging in our ordered pair for x and y. Okay, looking at example 3, this time we have y equals negative 1/2 x plus 4. Our second equation says x plus 2y equals 8. The first equation we have has been solved for y. The y is by itself. Since the y is by itself, we're going to take what it is equivalent to, and we're going to plug this in for the value of y. We have in our equation x plus 2y equals 8, and then I'm going to substitute in the value for y, and the value for y is negative 1/2 x plus 4. Everything else stays the same. I still have x, I still have plus 2, and we still have equals 8 at the end. But in place of y, we are replacing this or substituting negative 1/2 x plus 4. It has to be what it is equivalent to. We're going to distribute the coefficient in front of this parentheses. And 2 times negative 1/2, or half of 2, is 1. A positive times a negative is a negative 1x. 2 times 4 is 8. And then everything else stays the same. We still have equals 8 at the end. We still have x in front. We've distributed the 2, and from our parentheses we got negative x, or minus 1x, plus 8. Now we're going to combine like terms. In front of this x, there's a 1, so we have 1 minus 1x. Well, 1 minus 1x is 0x. We have 0x plus 8 equals 8. 0 times anything is 0, so 0 times x is 0. 0 plus 8 is 8. We find that 8 is equal to 8. We no longer have an x or y value. We're trying to find the values for our ordered pair. Since our x and y have gone away, we're going to look and see if we have a true statement or a false statement. 8 equals 8 is a true statement. That means for this problem, there are infinite solutions. That means if I pick an ordered pair on the first line, it would have to be an ordered pair on the second line. Or if I can pick values for the second line, they would also work on the first line. Since there are infinitely many solutions to this, we could choose a point on either of these lines and it would be a point on the other line. These two lines would be coinciding. That means if we graph them, it would be one line on top of the other. They're the exact same line.